All right, so yeah, welcome back to my channel. Welcome back to this YouTube channel. So yeah, in the last video I have wait a minute. Yeah, good. So in the last video, it's in last video I have covered a specific CNN architecture. Let's I have covered an architecture called ResNet. Just wait for a moment. So yeah, in the last video I have covered an architecture called ResNet. So in this architecture was actually it solved a problem. It solved a problem called vanishing gradient, where we can you know sh- uh, where we can give more importance to little features, rather than just giving more importance to following layers, like to the last layers. So in this now, so in this video we are going to discuss another type of architecture, CNN architecture called Inception. So the idea is very simple here. Like CNN architectures are pretty easy to understand. So the idea is pretty simple. We just like whenever you are like doing a whenever you are building a convolutional neural network, the one of the hyper parameters that you should select very carefully is the size of the kernel. That's right. So the size of the matrix that you want to perform a convolution on, right? So you'll have this matrix and which will slide through the image, right? So you should be very careful when selecting that the kernel. So one interesting study that has been happening in the field of computer vision is using using like one by one kernel, right? So when you can have one weight that just goes through all of these pixel values and scales each pixel value, and one this one by one kernel was actually a very good idea, and it helped to it not only decreased the number of computations, right? So you just have one right, so you just have um, one dimensional matrix or or just a single number, and that just scales each pixel value. And this idea was not only simple, right? So you only have one value to optimize, of course, and then it also scales the image such that it is easier for the following layers to perform their computations. So like we have many more kernel sizes. So kernel sizes does matter. They while doing research, different kernel sizes has have brought um, like huge changes to the performance of the model. So therefore, in the inception, rather than you picking up the best kernel size, so you don't have to pick between 3 by 3, 5 by 5, and 3 by 3. So what you can do is you can just apply all of these kernel sizes at the same time, right? You just apply all of these kernel sizes, right? So you have all of these kernels and you apply all of them, and then you get the output and concatenate them, and then you can perform the computation. And this inception model was surprisingly very good. The idea was the idea was very simple, right? But still the performance was pretty good compared to the um, feed forward neural network. So now that's it for the theory. I'm going to go through this video very fastly. So now let's just develop this inception network. We have this code from the last video here. I'll just change something. I'll change the variable name to inception, of course. Wait a minute. Inception. And I'll change the function, right? So the function is inception v3 dot inception v3. So v3 is actually nothing but more it's not it's more complex, right? So we have v1, which is like the base model, and then v2 we have many more layers and all that. V3 has, I think, has many more layers. I'll say inception here, and I'll put inception here. That's it, right? I'll just run it to see if it works. Okay, which has not inception v3. I think there is a spelling mistake here. I'll just go through. Sorry, I'll just go through TensorFlow library. As I said, tf.keras.inception. Yeah, it is. Yeah, so it is inception vt dot inception v3. I think I have to put that in capital. I have to put v in capital, right? I'll run it. I'll run that again. There's another problem here. Input shape should be that. I'll just let's just go through the documentation. I shall just go through this web page. It's very important. Whenever you are developing any models in TensorFlow, just go through the documentation. They have their official web page, tensorflow.org, and then any command or any function that you're using in TensorFlow, you can just check out here. So I'll just copy that. I'll just copy this and let's paste it here. I'll just paste it here. All right, and then let's include the top. Let's set include top is equals false. Let's weight is equal to ImageNet. Input shape, I'll put 150 by 150 by 3. And then classes, number of classes, we have 5 classes. And then let's run it now. Hopefully it runs. Just I'll just put Inception here, right? Hopefully that works. Yeah, the model. Okay, wow, layers is not defined. Okay, it's actually layer. My bad. Yeah, no, must always be passed. What is the problem? I think this is the problem. Put only one square bracket, I think. Yeah, it is working. Now let's compile our model. Let's compile. Good. Now let's train our model and see how it performs. First, we'll freeze the inception layers weights. I don't think it will perform that good because the weights are frozen. Right. Um, that's actually good results. Actually, we have frozen the trainable parameters we are not optimizing the parameters of the inception, but it is performing very well. Wow, it is actually hitting 96%, 94. Let's see 99. Okay, yeah, 100% accuracy has been hit, and yeah, it is performing pretty good. Like it has overperformed resonate, I think, because in this data set that we're dealing with, there are no minute features, so therefore resonate was not that good. And I think inception worked because it's just general, doesn't matter what the problem you are solving. But while using resonate, when there are very small images and when careful observation is needed, then go with the resonate model. When you are doing image classification, when there is a need of careful observation, just go through this resonate model. And when you have a general problem, I think inception is good, right? I just wanted to go through this research paper. I couldn't go through this because of lack of time, right? So just go through this. They have some good, like, huge models, and just go through this. And I think you'll find them useful. So thank you for watching, and I think see you in the next video. A minute, I'll just stop recording.